Okay, find a great many intercepts, they say. We should be able to knock these off kind of fast. Y-intercept here will be y equals 2 times 0 minus 6. The y-intercept is negative 6. For the x-intercept, we say 0 equals 2x minus 6. Add 6 to each side. Divide by 2. Okay, so this has 0, negative 6 is its y-intercept, and 3, 0 is its x-intercept. It's a straight line, so not surprising that it has one of each. For x squared minus x, which is a parabola opening up, if we put in x equals 0, we get the y-intercept, which is 0 squared minus 0 equals 0. And if we say y equals 0, we get x squared minus x equals 0. Factor it. And so either x equals 0 or x minus 1 equals 0, which means x equals 1. Do you notice we get the same point twice here? This parabola actually passes through the origin. It goes through 0, 0, and then it comes back up through 1, 0. There's 1, 0. So the origin counts as an x-intercept and a y-intercept, and so you're going to find it twice. If you look for your y-intercept and discover 0, 0, you know that's going to come up again when you do your x-intercepts. There it is, and then we got another x-intercept also. So that duplication is no big deal, and it actually happens kind of often, but it can weird you out if you've never seen it before. Let's see what happens with these. Here, if x is 0, we can kind of shortcut this, right? You can see what's going to happen. This term will vanish if we plug in 0. So will this one. All that will remain is negative 8. So if you have in polynomial form, if you have something like this, all the terms are going to vanish except for the constant, and that's your y-intercept. Now when we get to x-intercepts, we have 3x squared plus 10x minus 8 equals 0. Is this factorable? Are there two numbers that add up to 10 and multiply to minus 24? Methinks there are. I think we can do something with 12 and minus 2. If we factor that, we can pull a 3x out of the first two, which leaves us with x plus 4. We can take a minus 2 out of the next pair, which leaves us with x plus 4. The fact that we have x plus 4 twice means that it's working. We have x plus 4 as one of our factors and 3x minus 2 as the other, which means our x-intercepts are negative 4 and take 2 to the other side, then divide by 3, 2/3. So, as parabolas often do, this has a y-intercept and two x-intercepts. And here's the trig again. 3 sine x here's sine x. That's regular sine x. Now this one has a vertical stretch factor of 3 on it, so really it should look more like so. Will that matter to our intercepts? I suspect not, but we'll try to do a good job with our graphs anyway. So y-intercept we'll start with. For the y-intercept, you say x is 0, so you get y equals 3 sine 0. The sine of 0 is 0. Multiply that by 3 and it's still 0, so that means our function goes through the origin, and indeed our graph kind of predicted that. So we know when we do x-intercepts, 0 is going to be one of them as well, among others. For x-intercept, we say y equals 0, so 3 sine x equals 0. Divide by 3, you get sine x equals 0. And this comes back to knowing the unit circle. Where are the places where sine hits 0? It happens at 0 degrees. Then it happens at 180 degrees. Then it goes negative, and then it comes back and hits it again at 360 degrees. And those angles in radians are 0, pi, and 2 pi.